Okay, so solving absolute value equations. We've got to keep in mind here, as the first statement gets into this, is hey, the absolute value of -4. What is that? Well, it's 4. All right. Well, what about the absolute value of 4? Well, yeah, that's also 4. Because remember, absolute value is the distance from 0 on a number line. So even though we had two totally different numbers, a -4 and a +4, we still got the same answer of 4. So when we're solving these absolute value equations, we're going to have two different possibilities for a solution that can still give us the answer because we're eventually going to take the absolute value of it. So let's walk into this here. Steps wise, all right, here's what you've got to keep in mind. When you are solving absolute value equations, all right, the first thing you've got to do is you've got to isolate, all right, those absolute value bars. You've got to get them all by itself. The other thing that you've got to make sure that you end up doing is you set up your two equations. Because remember, one of them can be positive and the other one can be negative. Because when you take the square root of a -4, you get 4. And you take the square root of 4, you also get 4. So let's look through question number 1. Isolate first of all. So I see my absolute value bars. I've got to get rid of who's around it. And we're still going to end up using our normal solving equation skills. Undoing addition and subtraction first, followed by undoing any multiplication or division. So, yeah, undo it. Let's subtract the 1 from both sides. So we've got 3 times the absolute value of x minus 12, all right, and then equals our 15. Now, again, notice we've undone our addition, but now we've still got to get rid of that 3. Well, that's being multiplied because it's up against it. So we'll divide both sides by 3. So we've got the absolute value of x minus 12 equals 5, because 15 divided by 3. Okay, so we have isolated. Check. Now we have to set up our two equations, because remember, a positive and a negative, when we take the absolute value of it, still gets us to the same answer. So our one equation we're going to write out is x minus 12 equals 5. So really all we're doing is ripping off those absolute value bars and leaving the first one alone. The other equation is going to be x minus 12, but -5. And so there's your two equations. You always make one positive, or I guess we should say we always leave one alone. And then for the second one, we always end up taking the opposite, which is going to be your negative. So let's solve. In the first one, we'll add 12 to both sides, and we get x equals 17. For the bottom one, we're also adding 12, but this time, -5 plus 12, yeah, 7. So x equals 7. Oh, here's the idea behind it. If we do our check step and plug it in, like go in here and you replace it, 17 minus 12 is 5. What's the absolute value of 5? 5, all right? But look what happens when you plug in the 7. 7 minus 12. Well, that's -5. But what's the absolute value of -5? 5 as well. So again, absolute value equations, seek out those two particular solutions. All right, let's find another one to look at here. Let's go. Okay, so 6 is just like what we did. All right. Oh, I went too far. Hold on. I thought it was about the first page. Let's go after problem number 2, actually. It's right there the entire time. Okay, undo any addition or subtraction. Now, as much as it doesn't look like it, yeah, we're going to undo by subtracting a 5 from both sides, because technically that 5 is being added on. That minus sign, that's with the absolute value bar. So remember, we're always looking to the left of it. So, you know, you want to put a little plus sign in there so you can better see it. So we've got negative absolute value of 2x equals -16. All right. So now, just like with your equations, we have a negative sign out there. So it's really a -1. So we're going to divide both sides by a -1. So 2x equals, sorry, the absolute value of 2x equals a +16. All right. I've isolated those absolute value bars. Now we're ready to make our two equations. So 2x is going to equal 16, or statements, 2x is going to equal negative 16. Yep, divide by 2, x equals 8. Divide by 2, x equals negative 8. So sometimes they're opposite numbers of each other, a positive 8 and a negative 8. Other times they're two completely different numbers. And you'll start to see patterns with that, because if you notice, there's no addition or subtraction inside this one where the other one was. Yeah, but again, you can do your check step if you want. But x can equals 8, or it could end up equaling negative 8. So there's our 2. You can write out your answers as two separate ones like I did above. You could include an or statement there. You could say x equals 8 comma negative 8. Like, all that's going to save the same message the entire time. All right. Let's see here. Let's go after... Wait. Problem 3. My goodness, I should have just gone straight down the line. No, 3 is a good one here. Watch what's going to happen here. All right. Yes, a little excitement in my voice here. Yes, because something shows up that we haven't seen yet. So, all right. Isolate the square root. The absolute value bars there. So just like I saw, I'm going to subtract 4 from both sides. All right. Very similar idea. Negative 2, absolute value of x minus 3 equals 6. All right. We're going to divide both sides by negative 2. All right. No issues here. No concerns. X minus 3 equals, and then negative 3. Remember, it's an absolute value bar here. Okay. So there's always something to be watching for. And in this case, something just showed up that makes me stop the problem. All right. The official answer here is no solution. All right. Now here's the reason why. Check this out. See my absolute value bars? Tell me what you can take the absolute value of and get negative 3 for an answer. There's nothing. All right. There is nothing that's available. So if you ever isolate your absolute value bars, but it's supposed to equal a negative, shut it down. Now, here's the thing though, all right? If you don't notice that, then you just go along your merry little way and you're like, x minus 3 equals negative 3. Or x minus 3 equals a positive 3. Like, you're still going to get like number answers. Like it happens, all right? And you'd be like, yay, x equals 0, add 3, all right? Yay, x equals 6, all right? But here's the thing. If you plug it in, it won't work. Plug in 0. 0 minus 3 is negative 3. The absolute value of negative 3 is 3, all right? And then you've got 4 minus 2 times 3 equal 10. Well, that's 4 minus 6. 4 minus 6 ain't 10, all right? So you can check it at the very end, but it's something you got to be on high alert for. Anytime your absolute value, once it's been isolated, equals a negative, shut it down. Shut it down. We ain't doing it, all right? No solution. Move forward. So it is something that you do need to watch for. All right. Finally, the second page that we're getting to, that I've been constantly flipping past. Let's look after someone like problem number 5. All right. And in problem number 5, nothing ultimately fancy here, but in this case, to isolate the absolute value symbol, we're going to have to multiply both sides by 4. All right. And again, because we're dividing it by 4, so we'll multiply by 4 over here. If you'd like to, make the fraction so that you can see it. The 4 is upstairs, the other 4 is downstairs. 4 divided by 4, there's your 1. So yeah, I've isolated 2x plus 1 equals 12. All right. Now I'm ready to write out my two equations. 2x plus 1 equals 12. All right. 2x plus 1 equals a negative 12. Subtract the 1s. All right. 2x equals 11. Divide by 2. All right. So yeah, I mean, we get 11 halves. That's fine. Subtract the 1. 2x equals negative 13. Divide by the 2. Okay, we got x equals negative 13 halves. So yeah, x equals 11 halves, or it could end up equaling negative 13 halves. So those can be our possibilities for our answers. So again, lots of different ways of writing it out. Just make sure you have the two of them listed out regarding those particular items. I think we're in a good spot regarding it. Yeah, let's shut it down right there. Remember, isolating your absolute value bars, then you have to make your two equations to finish things off. All right, we're set.